scientific number format. Okay, so this is basically how scientists write down numbers. Okay, so the reason we do write it down in this kind of special way, so instead of actually writing down the number of meters that is the radius of the Earth, okay, we tend to use this kind of notation where we have some number that is between 1 and 10. Okay, so it could have any number between 1 and 10. Obviously, use the right number for the quantity times 10 to raise to the power of something. Okay, so we do that because, and this is really common in geosciences, also physics use this quite a lot as well. It's because the numbers that we typically deal with are either really, really big numbers. Okay, so this is quite a big number. So the radius of the Earth is 6.4 times 10 to the 6 meters. Okay, so we're using this SI units there. So that's 6.4 million meters. Okay, and if we were to write that out, that would take a lot of zeros. Okay, and there's another reason why we use this format rather than writing out all of those zeros, because actually this provides more information to how precisely we know that number. Okay, it removes any ambiguity. So this 6.4 times 10 to the 6, that number would suggest that we only know that to plus or minus 0.1 of a million meters. Yeah. So if we actually wrote out that number begins with a 6, or yeah, so that's the same number as 6.4 times a million. Yeah, that number and that number are the same. Okay, so which is the same as saying 6.4 times 10 to the power of 6. So 10 times itself 6 times is a million. So if we wrote out this number here, I mean, what if the Earth's radius was exactly 6.4 million meters? Okay, we've written out lots and lots of zeros here, so that suggests that we actually know it to that degree of precision. Okay, and we'll come on to this importantly later. Whereas actually this, if we write it like this, 6.4, that suggests that we actually, that could be that could be 6.449, so 4. So it could be that big, or we could actually be 6.35. So we know times 10 to the 6 is 10 to the 6. So if we knew the radius of the Earth was somewhere in between these two numbers, okay, we would write down that it's just 6.4, okay, because 6.449 rounds down to that, 6.35 rounds up to that. So we know that our measurement is somewhere around this 6.4, but if we wrote down 6.40, that would suggest that we actually knew it to that increased degree of precision. We'd know it more accurately, okay? So this is why scientists use this notation, okay? So we don't just give it to one decimal place, we give it to the number of decimal places that we are confident that we know the answer to. And this is really important, okay? You will get marks, or you will lose marks for quoting answers to the wrong number of significant figures, okay? Okay, so these are some kind of some more examples of this kind of stuff. There we go. The planet is very, very big. Things that happen on the planet, so weather systems, are kind of maybe an order of magnitude. So an order of magnitude just means 10 times smaller. But other things we're interested in are things like diatoms. Okay, so diatoms are a kind of plankton that live in the ocean, and these are 2 times 10 to the minus 5 meters. So that's essentially your. So with the minus 5, that's 2 times 10 to the minus 5 is the same as saying 2 times 1 over 10 to the 5. Okay, so that's the same as 2 divided by, so that's essentially 2 divided by, yeah? So 2 divided by a big number is a tiny little number. Okay, so these are the kind of orders of scale, 11 orders of magnitude. Okay, and using those rules, okay, about how you, if you're dividing or multiplying these numbers together, it allows us to use these exponents on the 10, okay, because the 10 is always the same number, it's always 10, so we can use these rules. Okay, if we use 6.4 times 10 times 9 to the 6 and 2 times like 11 to the 5, we wouldn't be able to then manipulate the exponents using those exponential rules. Okay, so because we have these common kind of times by 10 to the power of something, we could use this to say, well, how many diatoms would it take to fill up the Earth? Just by dividing this number by this number. Okay, we could do that very simply now in our head. Okay, because we divide 6.4 by 2, which is 3.2. Okay, 10 to the 6 divided by 10 to the 5 is 6 minus minus 5. 6 minus minus 5 is 11. So there would be 3.2 times 10 to the 11 kind of diatoms if we stack them up all along the radius of the Earth. I mean, that's a ridiculous calculation to do, but it just gives you an idea of the kind of manipulations that are now quite easy to do without a calculator to do this kind of thing. Okay, so this is kind of the general form. So this C is that number that determines the value, the value of our kind of our thing that we're measuring or representing. B is almost always 10, and E is the exponent. So how much we're basically the magnitude of that measurement. Is it in the tens, which would be a 1? Is it in the millions? It would be a 6. Okay, that's what all those things say there. Okay, so okay, here's a nice example. Okay, so this is one where we've added more digits after the decimal point because we're more confident about the precision of that number. Okay, so just more examples of this kind of pointless things, and we could work out what those things are. Okay, and yeah, so in science, these when we're measuring things, sometimes we have these prefixes for numbers. So a kilogram is 1,000 grams. So 1,000 is 10 to the 3. So usually when you have a kilometer would be 10 to the 3 meters. A megameter would be 10 to the 6 meters. A gigameter would be 10 to the 9 meters, so a very long distance. So there are a whole bunch of prefixes that go with these things. So we go from femto, which is 10 to the minus 15, so that's a very, very small quantity. So a femtogram, if someone said, oh, I can give you a femtogram of gold, you go, yeah, thanks, because that would be 10 to the minus 15 grams of gold. There's probably that amount of gold in dust. Okay, because it's such a small number. But if I was to give you a gigagram of gold, you'd say, oh yes, I'd like that very much. Well, what you would do with such a huge quantity of gold is kind of incomprehensible. Anyway. Yeah, so I think, yeah, so I just get all of these things up here for now. Yeah, so this is just a note that when you are using these numbers on your calculator, if you've got a calculator out, you should be able to see that there should be a button with EXP on it. Yeah, can you find that button? So this is important that you need to get to know your calculator, okay? Because your calculator may be different to other people's calculator. So if you wanted to type in 3 times 10 to the 3, this button on your calculator, EXP, okay, actually does all of that for you. So you might, on your calculator, have to just press 3 and just press the X button and then 3 again. Okay? So the X button can, on your calculator, depending on the model, kind of replicate all of this times and 10. Okay? So have a play with your calculator and you figure that out. Now, I know Massimo said yesterday that quite a lot of your tutorial work will be using Microsoft Excel, okay, or OpenOffice or whatever you have. So Excel also has a function, EXP. Okay, it is not the same. It does something completely different. Okay, so in Microsoft Excel, to get this, you just type into your that is us done for today, I think. So it's like I said at the beginning, so we haven't finished the lecture as far as the PowerPoint is concerned, but we'll pick this up kind of next week. So this hopefully has given you enough to kind of start on with the tutorial sheet, which should now be live on Learn. Okay. So we'll come back in the next lecture, and I'll put some of the examples live on Top Hat, so you can like have fun with maths. Okay.